Welcome to the Human Systems Engineering Department virtual tour. We'll be exploring the Horizontal Accelerator Lab, the Human-Computer Interaction Lab, the Digital Night Vision Lab, and the Environmental Physiology and Human Performance Lab.
My name is Maria Thorpe, and I am the Director of the Human Systems Engineering Department. The Human Systems Engineering Department provides and supports the research tools and equipment development necessary to ensure that naval air crews can safely perform and survive both physically and cognitively in what are often extreme and stressful aviation environments. In this tour, we'll explore how the Navy develops technologies to create an environment where naval aviators and maintainers are provided the tools that allow them to perform their mission safely. This includes understanding the impact on the brain and the body of mission or environment stressors such as acceleration, high altitudes, noise, laser radiation, and thermal stresses. Our specialized laboratories are equipped to protect aircrew against the myriad of stresses, but also to quantify the effects of these stressors and develop and test the means to mitigate the injury risk our warfighters incur and support them in every manned and unmanned naval air vehicle. Now, let's go and explore the Human Systems Engineering Department labs.
So I'm John Daly. I'm the Dynamic Test and Modeling Branch Head in the Human Systems Engineering Department, and I'm responsible for test and modeling on anything that we think might be an issue for crew safety during an ejection or a crash. This is the Horizontal Accelerator, or the HA. This is the Navy's crash test lab. This is where we simulate helicopter crashes, ejections, other high-speed, high-acceleration events that we think might cause an injury to aircrew, and look at ways of reducing that potential for injury. The Horizontal Accelerator is a pneumatically powered crash test system. It's up to 3,000 psi of air in the cylinder, and then the ram pushes the sled down the track with 250,000 pounds of force. It could be up to 60 Gs depending on the test. We can orient the seat in different directions to simulate horizontal crash or vertical crash and look at the potential for human injury during that event. We use high-speed video on all the tests. Our cameras are shooting at 1,000 frames per second, which is about 30 times the speed of a normal video camera. That allows us to slow down the action. It's synchronized with the data so that we can see exactly what's happening at the moment that the loads are highest or the accelerations are highest. On all of our tests, we use anthropomorphic test devices, or ATDs, crash test dummies. We can instrument those and see what would happen to a real human during those events. We can install accelerometers in the head, the chest, and the pelvis. We can put load cells that measure force and moment or twisting force in the upper neck, lower neck, the lumbar, basically any place that we would see an injury in a human. We can measure that during a test and see how a person would have done during that test. The HA is a very repeatable system. It works like a crash in reverse. So instead of, for example, taking a vehicle and running it at 30 miles an hour into a barrier, we'll start it stopped up at the ram and then push it backwards at 30 miles an hour. The physics are the same, and it allows us to set up everything without it moving until the moment of the test. And then the HA itself is a very repeatable system, so it allows us to do straight comparisons. We can look at a new helmet versus an old helmet and see if that would increase forces on the neck during a crash, or we can look at a new restraint versus an old restraint and see how that performs. Look at a new stroking seat versus an old seat and see how it performs on lumbar loads during a test. Another unique capability for naval aviation is the parachute opening shock emulator, or POSE system. We use this to simulate the seat separation phase of an ejection. When a pilot pulls the handle on an ejection seat to escape out of an aircraft, the catapult fires the seat out of the aircraft, the rocket motor is lifted up to altitude, and then the parachute opens, and the parachute is attached to the pilot, not the seat, so it pulls the pilot free from the seat. And this is an area where you can see a high potential for injury. So we were looking for a way to simulate that easily without doing a $1 million rocket sled test. So we designed the POSE system in-house. This is a system where we have a seat mounted, fixed to the ground. The parachute lines are attached to the sled. And the sled pulls the dummy out of the seat the same way it would during seat separation. and that allows us to look at neck loading in a controlled condition. There's a net that safely catches the dummy after the test is over. So this has been a great increase in capability for us. The POSE system was designed using a computer model, so we have a very accurate computer model that was put together before the system was even built to verify out that everything would work the way we hoped it would.
My name's Thomas Rogers, and I'm a mechanical engineer for the Dynamic Test and Modeling branch in the Human Systems Engineering Department. So 2 projects I worked on. One was last year, it was focused on aerodynamics, kind of a parachute opening from an ejection of T-38. And that was kind of interesting because that's something our software isn't necessarily designed for. Aerodynamics is for crash systems. But we were able to model pretty accurately the ensuing ejection of the pilot, and the customer was very happy with the results. Another project I also worked on is using a newer feature in crash systems, which is an active human model, which more accurately depicts the muscles and activation of those muscles in a human during a crash, and that greatly changes some of the responses that you can see.
Next up is the Human-Computer Interaction Lab, or HSIL.
I'm Matt Laycock, and I'm the manager of the Human-Computer Interaction Lab, also known as HSIL. HSIL resides within the Human Systems Engineering Department at the Naval Air Warfare Center Aircraft Division. We have 2 primary services in this lab. First, we have a risk reduction capability whereby we prototype user interfaces and validate them, both hardware and software user interfaces, for U.S. Navy and U.S. Marine Corps platforms. Secondly, we're a research facility whereby we look into the state-of-the-art user interface technologies to determine whether or not they have applicability for our military weapon systems. We employ a wide variety of expertise in this lab. We have mechanical engineers, computer scientists, human factors engineers, experimental psychologists, and even neuroscientists. Our goal is to ensure that the warfighter is as efficient and effective as possible when executing their mission. And then we want to make sure that they come home safely. We do that by prototyping user interfaces that reduce workload, optimize their situational awareness, and optimize the overall usability of the weapon systems they're utilizing. One of the things that you'll notice when you enter the HSIL is that we have a variety of cockpits and simulators. We have low-fidelity cockpits and simulators and high-fidelity cockpits and simulators. When it comes to using low-fidelity cockpits, we're attempting to minimize the amount of cost and time it takes to validate certain designs. We're able to make valid recommendations to our customers without going overboard, without spending additional time or money on those efforts. However, there are certain cases when we need to replicate exactly the dimensions of a particular environment. For example, if a program comes to us asking for assistance with the integration of a physical component into an existing cockpit, we're able to replicate that environment in-house and then evaluate whether or not that new component obstructs the field of view of the pilot or could negatively influence the usability of the existing displays. Our primary customers of this lab are programs of NAVAIR. However, we also collaborate with academic organizations, with other U.S. military organizations, and of course, allied nations military services as well.
My name is William Harris. I'm currently an ESTP working for NAWCAD at Pax River. My current role is software team lead for the Human-Computer Interaction Lab. I went to school at University of Maryland College Park and got a bachelor's in computer science. I came to really enjoy the math side of that as well. At the Human-Computer Interaction Lab, we mostly make hardware and software mock-ups. We use these mock-ups to prototype user interfaces to identify risks and solve problems and make better user interfaces for pilots and the warfighter as a whole.
Next up is the Digital Night Vision Lab.
Hello, my name is Dr. Jennifer Prentice. I'm the Electro-Optics Branch Manager in the Human Systems Engineering Department, Human Performance Division. Our team's objective is to develop, define, and measure the performance of lighting and imaging devices. Most importantly, we make measurements and assessments to precisely understand what a human user needs in order to make optimally effective use of these electro-optics under every different condition that they might encounter, and how to keep that person safe and prevent strain, stress, or damage while they are using them. The electro-optics branch's most groundbreaking laboratory is the Digital Night Vision Laboratory. The DNV lab is unique compared to any other services night vision facility in that it is near absolute dark. It allows us to perform controlled testing within the darkest conditions seen out in the real world. Our night terrain board is a unique scale model that includes features such as water, mountains, roads, cars, towns and businesses, airport runways, towers, visual or cultural lighting and covert lighting examples, and has an overarching lighting system that simulates variable moon positions and luminance levels. Since night vision is the capture of reflected light, its transmission has to do with the reflective properties of the material itself, as well as the angular surface being reflected off of and the size and shape of objects or terrain that can create shadows or specular high-intensity mirror-like reflectance. The night terrain board lets us perform qualitative evaluations of night vision devices, overlooking typical terrain as it appears from flying altitudes over an area of 100 square feet and 270 degrees of viewing angle. Our night scene simulator projects dynamic, live-motion, real-world scene movies simulated from the perspective of an aircraft viewpoint in the near-infrared spectrum. We have full control over the scene environmental conditions. It simulates in-flight cockpit views and can be used with any and all types of night vision devices and near-infrared technologies. If you look at the projection with your naked eye, you don't see anything. Everything is black because humans cannot see in the infrared part of the spectrum without NVDs. Our 38-foot long eye lane can create simulated night conditions from full moon to overcast starlight. Using standard bar charts with accurately spaced lines, numbers, figures, and letters, we can evaluate what the resolution of the human can perceive at the various light levels through the night vision devices or goggles. The Digital Night Vision Laboratory has created a comprehensive and unique experimental, test, training, and demonstration facility for pilots, scientists, and engineers. It is positioned at the forefront of the transformation to the next generation of night vision devices and helmet-mounted displays. This exciting and essential area of science and engineering investigation and technology integration in human systems is critical to the safety and the performance and function of our operating forces in their daily lives.
My name is Jesse Sheldon, and I am a physicist. So right now I work in the Digital Night Vision Goggle Lab. I'm working on the S&T side, which means I'm looking for out in industry technologies that can help the warfighter perform their mission, basically trying to transition those technologies to the fleet.
Next up is the Environmental Physiology and Human Performance Lab.
Hello, my name is Michelle Warren, and I'm the lab manager for the Environmental Physiology and Human Performance Lab, or EPHPL. The lab's mission is to study the human physiologic response and cognitive performance in simulated real-world combat conditions. This includes the human response to extreme thermal temperatures and noise, altitude effects with reduced oxygen, and equipment testing in extreme thermal environments. Our studies take place in a temperature-controlled environmental chamber that can go as low as -30 degrees Fahrenheit or as high as 160 degrees Fahrenheit, and we can change the humidity from 5 to 95%. In the chamber, we look at the human response to thermal stress and figure out ways to mitigate it. For example, we can have our volunteers exercise on a treadmill or a bike to increase their core body temperature and then try to decrease it using some prototype cooling devices. The chamber has a large water immersion tank with controlled water temperatures that allows us to simulate open water conditions with 1-foot chop and spray from the ceiling. This is useful for evaluating immersion suits, life jackets, or other equipment. To monitor our volunteers, we have cameras, temperature sensors, audio monitoring, and for physical measurements, we collect core body temperature with wireless pills, skin temperatures, heart rate, respiration rate, and blood oxygenation level at multiple locations. We also have several multitask computer programs we use to look at cognitive performance. Many of our devices are portable and can be used to conduct research in the field. We conducted a cooling study with 12 volunteers in full ChemBio gear instrumented wirelessly. We have fixed wing and rotary wing flight simulators that have been ruggedized to withstand the extreme environmental conditions of our chamber. We conducted a multi-stress study with volunteers to investigate how hypoxia, heat, and noise influence simulator performance, first individually and then combining stressors to see performance decline. Simulated altitude testing is currently being conducted with the Reduced Oxygen Breathing Device, or ROB-D. We have determined how cognitive ability declines at simulated altitude of 18,000 feet up to 25,000 feet in the cold, as well as when exercising prior to and during hypoxia exposure. Currently, we are conducting research with PMA 202 aircrew systems to evaluate several prototype sensor systems to predict and alert aircrew of hypoxic conditions. Research in thermal mitigation, hypoxia stress, and physiological monitoring is an ongoing field where advances in technology make current and future research a necessity for helping the welfare of the warfighter. EPHPL is ready to meet that need.
Next up, we're going to hear from some of the members of the Engineer-Scientist Development Program about their experiences working in the Human Systems Engineering Department.
Hi, my name is Ashley Wheeler, and I am a biologist in NAVAIR. My typical day consists of meetings and testing at the lab. However, I've had the opportunity to meet great people here, and that has landed me different projects, from working with the V-22 to testing for the presidential helicopter. The highlight of my career has been being able to go to different hangars and tour the aircraft that are housed in there. And then another one of my highlights has been getting ejection seat certified. I had to put on all the gear that pilots do. That was a really fun experience.
I went to school at University of Maryland, Baltimore County, and I studied mathematics and physics. I really enjoyed my rotations as part of the ESDP program. They let me work on some really cool different projects outside of my lane. One of those was the Innovation Challenge. I was part of a team that made a prototype sonar system. So getting to work on acoustics versus optics was really neat. I got to work with VR, Unity, a lot of 3D modeling software. I learned a lot through both of those rotations and really enjoyed them.
I'm from Bethesda, Maryland, and I went to the University of Maryland, College Park, and studied mechanical engineering. So I do a lot of modeling and simulation for crashes of aircraft and rotorcraft, and also work with other groups for any sort of dynamic modeling they need. I chose engineering kind of in high school. I was on my robotics team, and that was something that was very interesting to work with. And I realized there's a whole career field kind of dedicated to that with mechanical engineering.
We asked the Human Systems ESDP interns for their best advice for someone interested in pursuing a career in engineering.
My advice to someone considering a tech field or coming to work at NAVAIR is to pursue kind of technical hobbies that you may have and try and learn a lot from those, because those things can be really fun, like the virtual reality. That was kind of already a hobby of mine. 3D printing was a hobby of mine. Just having a little bit of knowledge of something outside of your lane can be a big benefit.
My advice for those interested in engineering is to ask a lot of questions. It's something that you will do throughout your career, but it's very important and will help you progress and learn a lot more.
My best advice is to be a lifelong learner, not just learning for your career, but also learning from people. People have so much to teach you.
One of the best skills you could pick up for yourself is computer programming, and something you could do at home while you're bored. You just have to set out, pick a language, and make something. Getting over that first hump makes everything easier, and you can keep practicing and keep practicing, and if you enjoy it, you can even make a career out of it.
I hope you enjoyed the overview of the labs and facilities of the Human Systems Engineering Department. Even though you only saw and experienced a few of the facilities, we have well over 25 labs with many teams working in a collaborative environment to ensure information sharing and communication across facilities. This allows for our naval aviators and maintainers to perform their mission safely and return to do it again. Thank you. I'm Ellen Cervetnik, the NAWCAD Strategic Education Office Team Lead. We hope you enjoyed this video. If you'd like to learn more about NAWCAD's Education Outreach Program and activities for students in kindergarten through 12th grade, please email us at nawcadeoo.fct@navy.mil, or you're welcome to visit our website listed on the screen. Thank you.